In this video, we are going to use this joystick for controlling the Turtlesim turtle, and this is going to be a small project, so make sure that you watch the video till the very end. And also, if you don't have a joystick, then don't worry about it. Just stay tuned and try to make the node with me. I will explain the node, how the node works and all those things. We will try to use this joystick for the Turtlesim controlling part. And for the people who have this joystick, then it's good. I'm using the red gear joystick. It can be any joystick. There is no hard and fast rule for that, and I'm not promoting the joystick wala part. But for the people who don't have it, you can just watch the video, and in the coming videos you will be able to do some practical things with the Turtlesim, because we are going to have one more project for it which can be implemented by anyone. So yeah, let's get started. So first of all, it is very important to install the Joy package for ROS2 Humble. So we will install that. If you are using any other ROS distribution, then you can install for that as well. So let's install the package. Install ROS Humble Joy. Okay, so it's Joy. Okay, so it is already installed in my device, but for the people who don't have it, make sure that you install it. The command was as we discussed. Okay, so let's get started with the node creation part. So we have created one node here. You can create the node by creating one Python script and then including that in the CMake lists, so that it will become the executable. We will import the necessary libraries, and here we will import Joy, okay, that we installed previously, because we are going to use this joystick. And then the twist message, because we are going to use the linear velocity and the angular velocity. And here we are creating the publisher and then the subscriber. Publisher to send the velocity messages, and subscriber because we are using the joystick. So for that reason we will get the commands from the joystick and use them to control the turtle motion. And here we have created the callback function for the twist message, and then the angular velocity. Oops, sorry, I also have to create here the linear one. So yeah, this got commented by me, but yeah, we have created the linear velocity for the joystick, and then the angular velocity to move the turtle using the stick. So I will show the joystick on the screen. So for this particular motion, we will use the left axis. So whenever we move the left axis forward and backward, it will move vertical or to the downside or else upside. And when we will move it left or right, it will do the rotation part, or like moving and getting the turns. So that part will depend on the axis. And then we have created the button mechanism. So whenever we press A, the turtle will move faster, or else the turbo mode will get on. So that's how it works. And also the message will be printed on the terminal whenever we press the buttons. The button rule is not like, if you want you can add the buttons, else you can skip that part. But after pressing the B, the turtle will stop, and then for the X button we are keeping it reverse mode to come back, and for the Y we rotate right. So that's how it works. It depends upon you as well. So if you change the linear velocity, it will, like for example, if I change it to 1, then it will move slower, or else if I make it -2, then the velocity will be much more slower, okay, or else to the reverse direction. And yeah, if you don't want to stop the turtle, if you want to just move the turtle to the left side, you can use B for that as well, by just changing the velocities here. Like for example, if you remove this twist dot linear.x and just only keep the angular one and make it 1.0, it will move anti-clockwise. So that's how it works. Similarly, for the backward motion, as I said previously, you can, if I make this negative, it will move backward. If you make this positive, it will move forward. That's how it works. And then we will publish the velocity and also print the commands by mentioning the current velocities. That could be the linear velocity and the angular velocity. Okay, and finally we will create the main function, and yeah, that's how our node will be created. Now let's run the node. So first of all, we will run the joy node, that is ROS2 run joy underscore node. Okay, so now it is working and it has detected the joystick. The next part will be to run the Turtlesim node. So ROS2 run Turtlesim node. Okay, the Turtlesim has started, and now here we will run our node that we have made for the joystick controlling part. So first of all, go inside the first of all the workspace, src, only workspace is fine, and then the call convert part. Okay. Sourcing it again, right? So now ROS2 run Turtlesim underscore project, and we have turtle joystick.py. Okay, so let's see how it works. So the node has started, and I will move the joystick now. So now I have made it vertically. Then moving, I'm just moving the stick for now. If I make the turbo speed using A, it's moving, and then again if I use Y, then it is rotating. For B it will stop, right? See, B has stopped it, it is not moving now, right? For Y it will take turns. For X it is moving backward. This is the working of the joystick node, and it was our project 2 for the Turtlesim node using the joystick. So yeah, let's meet in the next video with the new project. Till then, grow, learn and explore together.